Thanks. All right. Well, it's a pleasure to be here this morning. Thanks for joining us in beautiful Honolulu. For those of you that are not familiar with Rogers, and to provide some context for our discussion this morning, we are Canada's largest wireless and cable provider, and we offer a full suite of both wireline and wireless products from coast to coast across Canada. Okay, is that better? All right, great. And we are also the proud owner of the Toronto Blue Jays, the only MLB team in Canada. This morning's session is to share some thoughts around IoT connectivity and how we as service providers can enable all the different ways of IoT is being used to transform everyday life in the world that we live in. And as we talk about IoT connectivity options, 5G is fundamental, thank you, to that evolution, and here's why. Okay, there we go. Next one. Here we are. The world is becoming more connected, not just between people, but between machines, sensors, and devices. The current wave of technical innovation has been referred to as the fourth industrial revolution. This fourth industrial revolution is described as the current developing environment in which disruptive technologies and trends, such as the Internet of Things, IoT, as we all know, robotics, virtual reality, and artificial intelligence are changing the way that we live and work, and fundamentally, the way that companies operate. Businesses increasingly rely on connected devices to deliver services and optimize operations, and it doesn't matter what industry you're in. The way in which we provide connectivity will impact our customers across industry and around the world. As you can see here, the rate of growth is exponential, and it's estimated that between 2017 and 2026, increases in productivity driven by IoT will result in $10 trillion in profits and cost savings for organizations. Billions of connected devices, trillions of dollars invested. So let's take a look at the evolution of wireless networks and how they have rapidly enabled IoT and other technologies across the years. Some of you may remember the very first cell phones back in the 80s with the introduction of 1G analog technology. That was huge, along with the size of the phones. The use case was revolutionary, but fairly simple. It enabled customers to make mobile phone calls. 2G in the 90s was digital and enabled text messaging. Device size and price also started to come down dramatically and made it more accessible. You could put your phone in your pocket. Fast forward to the 2000s and 3G. This was really a milestone in terms of using wireless for data. 3G and the development of smarter devices like the BlackBerry, another great Canadian invention, powered email and internet browsing and changed the ways that we started to use our devices. And providers got together to provide a global platform and enable global roaming. Most recently, 4G speeds delivers faster speeds and was a key trigger for the on-demand economy. 4G is a game changer, enabling IoT and specifically massive IoT. 4G provides connectivity that is designed for scale and paves the way for 5G, which is designed for performance and to enable mission-critical applications. Over the next several years, 5G will transform businesses and industries with real-time economy powered by increased speed and capacity, further scale in terms of the number of devices that can be connected, and lower latency. So while 4G has enabled massive IoT, 5G will enable mission-critical IoT. So no question that 5G is a game changer. But first, let's talk about two IoT connectivity options that are used today via 4G, LTE-M and NB-IoT. Let's just see if this... There we go. Both leverage low-power wide area, or LPWA, wireless technology, which is optimized for IoT and enables the connection of large volumes of low-cost devices while providing increased range and signal penetration. Some of the key benefits include enhanced coverage, extended battery life, large implementations, and carrier-grade security and reliability. So how do you choose the right LPWA technology? First, we have LTE-M. It leverages existing LTE cellular networks to provide extended coverage to IoT applications. Due to its lower latency and higher bandwidth, LTE-M is ideal for applications where devices are in motion, real-time data or voice services are required, and where data protection is a concern, and it also supports data rates up to a meg. And while many traditional IoT devices are designed to stay in place, LTE-M supports mobility or cell site handoff, as well as global roaming, and it enables applications that are not stationary, such as monitoring shipping containers that move from country to country, fleet vehicles, auto telematics, or even people with wearables or tags. Then there's NB-IoT, or narrowband IoT technology. It's engineered for fixed stationary assets and ultra-low bandwidth applications offering data rates at around 200 to 250 kilobits per second. It provides better connectivity in subterranean locations such as basements, utility vaults, and sensors located deep within buildings. It's ideal for IoT applications that are latency tolerant, operate in difficult radio conditions, and to monitor stationary assets. And it's also ideal for devices that generate and receive very low amounts of data, have low power requirements, or have a very long life cycle. NB-IoT is a great solution for stationary applications such as pipeline monitoring, in-building monitoring systems such as an HVAC, and utility applications. So we've talked about the evolution of wireless technology from 1G to 4G and how it will transform businesses and industries with increased speed and capacity, more efficient use of spectrum, improved battery life, and lower latency. Once fully developed, 5G is supposed to offer download speeds of at least 2 gigs per second and peak speeds of up to 20 gigs. This is about twice as fast as the 4G networks today. It will support 500 times as many connected devices than 4G, and theoretically can reach latency as low as 1 millisecond. It will also support the massive increase in the number of connected devices that require near instantaneous latency for applications like augmented and virtual reality, smart communities, remote patient healthcare, robotics, and driverless vehicles. So what's needed to support all of these different use cases? Well, first we'll need 5G-enabled wireless networks to connect to the millions of IoT sensors and devices along with all those smartphones and tablets. Second, the only way to move massive amounts of data from the wireless networks will be over robust, low-latency fiber optics. And that fiber network will need to be well connected to other carriers and networks as well as the internet. And in order to achieve the optimal latency, the compute will need to be closer and closer to the edge of the network. Thirdly, all that IoT data needs to go somewhere to be processed and stored, and that's where having all of the necessary connectivity to data centers and cloud providers is critical. Customers want a single service provider that can provide seamless connectivity from sensor to server and all in the blink of an eye. We're going to end with the video here to show us what's possible. But before we do, I have to say that our session this morning is extremely well timed. Last Wednesday, it was announced that Canada's first 5G network was being rolled out in downtown Vancouver, Toronto, Ottawa, and Montreal to be ready for when 5G devices become available this year. It was also announced that the 6 major carriers, including Verizon, Vodafone, Telstra, KT, America Mobile, and Rogers, have formed the 5G Future Forum, a group that will collaborate on global 5G interoperability with the goal of accelerating the delivery of 5G and mobile edge computing-enabled solutions. There we go. So thanks for joining us this morning, and in the words of Ted Rogers, the best is yet to come.